Hello, welcome back to Blender Sushi LiveENODING. So in this episode, I will try to recreate this abstract animations by Concinnus. I was looking at this for a while and kind of thinking, hey, that's kind of like a really nice animation pattern that I really want to recreate this using Blender. Even though this is like simple, imagine this is like a bunch of lines in horizontal and vertical, and then they're kind of changing in radius at different time. This is kind of interesting to recreate. So I will try. I actually try using spare chalk, and I came out with this. So it's kind of a very similar result, and I actually started by using plane. So this is what I got at the moment. And I can actually increase the number, and it's a bit more parametric now. It's actually pretty okay, I think. It can be improved with noise. Currently, I'm just using a sine wave. So I'll try to break this down real quick. So I started with a plane grid. Don't worry about this number. And this plane has the vertical and horizontal lines in a way, and I can break it down using UV connection. So that's why I have these two guys, and I turn on the separate to make sure that I get a proper line for the U and the V. Actually, I'm only using the U and kind of rotating it here using matrix Euler. Okay, that's because if we are using the V, we might get a result that's a little bit like this. So I want to get lines that looks like this. I'll show you what I mean. If I use a viewer draw for the UV connection here. So these guys actually all right. Let me hide this curve for now. So that's kind of okay, but the other guy, the V tend to create this kind of zigzag line, and I don't want that. So anyhow, so I'm just using the U for both, and then I'm rotating one of them. So, and the next thing I did was to use polyline viewer to create this curve line. And it is like just a bunch of cylinder basically changing in radius. And for the radius itself, I'm using sine wave to control the line. So this is the sine wave, the sine functions, and the sine function has an input coming from this frame number. With a frame number, I actually offset it using this random number. So if you look at it using stethoscope, you can see this is like the frame numbers coming in. They are all slightly offset, and from that guy, this multiplier actually should be this at the back. Okay, now it's slightly better. So this is time. We multiply the time. If you want it a little bit slower or faster, we can adjust this. And okay, so that's controlling the speed, and then this guy controls the offset of time, goes into sine function. So we have this kind of pulsing value. We can use this multiplier to control the amplitude of the sine wave, and map range to control how this sine functions, and make it between 0 or 1, like a minimum and maximum value for the radius of the cylinder. So this is how we get that value. And I'm using list split so that each value goes into each cylinder. if I'm not using list split, what I'm getting is something more like this. See, it's still pretty interesting, but that's not what we want. So yeah, this guy actually can be adjusted as well, like that. So here, the value is a little bit more abstract now. That's it has certain clamping. So what happened is the value coming in as a using these SINE functions, the value normally goes between minimum value and maximum value, and it goes like a wave like this. And using a clamp, if we are using map, range, and clamp, we can clamp the value like that. So in the end, we have a kind of animation that's kind of stop over there and then goes down and stop down there and goes up again. That way we get this kind of like a hold or like a break in between. That's kind of nice. You see, it's kind of stopped there at a minimum and then goes down and then goes up again. Say it leaves a room for some breathing. That's I think how Concinnus actually made that. He has a lot of very abstract animations and kind of feels, maybe I'll try to recreate some of them. Very interesting puzzle. Oh yeah, this is the classic one. Kind of want to do this using Blender Eevee render. Well, anyway, I'll look at it later. So there we go. That's how I think this can be recreated. You can use animation nodes as well for this, but I'm using sphere chalk because sphere chalk can generate mesh very easily. But I think it's really nice, very nice pattern there. Thanks to the inspiration, Concinnus. And so yeah, that's pretty much it for this live coding. It's hopefully you find this useful, and I'll see you in the next video. Thank you. Bye.